So this video is on security. For the purpose of this class, we will assume that anyone trying to access the systems without our express permission is a hacker. So we're going to look at the AAA of security, the 7 layers, encryption, and we'll discuss a little bit of TCP, IP, port security, and firewalls. So AAA stands for authentication, authorization, and accounting. So the first part is identification, where you have to identify who you are. So as you're trying to access a system, you need to have some sort of unique identifier so that you can identify who you are. Commonly that's done with a username. Sometimes we use signed ID numbers, such as your student ID we use here at the college. There's also something called a UUID, which stands for Universally Unique Identifier. And this is a very long code. It has 36 characters, which are hex value. 32 of them are hex values, and then some hyphens. And the idea here is that when you generate this, it should be unique, although there's no real guarantee that it is. But it's such a large random number, and if you look at the breakdown of this one, they're not all broken down this way, but this one here was generated on a system, so it uses the hardware address of the system, and then it uses like time values to encode, and so it as you can see, it looks very random, and it should be fairly unique, although again there's no guarantee that it is. Once you identify who you are, you say, okay, this is me. Then you have to prove it. Okay, so you have to verify, is it really you? So verification is done using one of 3 different things. Something you know, which is either a password or a longer passphrase, or something you have. So something you have, it could be a USB key, could be some kind of private key, a one-time password, or number 3 is something you are. Okay, so using something like a fingerprint or an iris scan that should identify you uniquely. Now, commonly what we do nowadays is we use multi-factor authentication. So the idea here is that you have to use at least 2 of these. So using just one, like say a password, it's pretty easy. Well, maybe not real easy if you have a good password, but for somebody to either find your password or guess your password, and they could have access to the system. Or if you use something that you have, such as a USB key or some sort of private key that was issued to you from the IT department, you might lose it or it gets stolen or something, and people could access it. But if you use at least 2 of these, it makes the security of the system much more difficult to break. Once you've verified who you are, then we have to look at authorization. Okay, so based on who you are on the system, that identifies what you have access to and what you don't have access to. And then accounting. So the accounting goes along with the authorization. So the system needs to track who's doing what they're accessing, and then you have to have audits performed on the system so that when you look at the system and you verify, oh well, is somebody able to access something they shouldn't, or things along those lines. So the accounting piece is a critical piece of your security. All right. So common protocols that follow this AAA is one of them is referred to as radius or remote authentication for dial-in user service. So as you can see, this has kind of been around for a long time. It's um, was developed for dial-up systems. Another one is called diameter, which is 2 times the radius. It's a play on the original radius, which just has some advanced features and it's optimized for cell phone networks. And then there's another one called Extensible Authentication Protocol. And this, like our standard Wi Fi security, uses this protocol. So when we're thinking about security, you really want to think of it in layers. All right, so we're going to go through 7 layers of security, but if you think of it kind of like as an onion, and you peel that back 1 layer, and there's another layer, and then yet another. So to actually get to the center, you have to continuously peel back layer after layer. And so that's to be very secure, that's what you want to do for security. So the first layer is the human layer. A lot of times this is kind of considered the weakest point. There's actually a lot of famous hackers that were able to access things that they were not supposed to simply because they were able to trick or steal the information from the human aspect, from a person. The next is perimeter security. So, we set up on our networks, we set up what's called a firewall, which is kind of like our border security to keep unwanted people off of our personal or business networks. And so what happens though, is we need to make sure that they don't actually just somehow get onto our property and plug into or connect to our network. And so that's our second layer. And then we have network security. So in network security, this is where we can apply the like the AAA, and actually most of the rest of these we can apply this AAA thing where you can only access the system if you have a user account and you verify who you are. Okay. Some other aspects that you need to do with this is you need to make sure that you install any updates regularly, that you use encryption, and you also use timeouts on your logins so that if you go away and you forget to log out manually, that the system will automatically lock after a certain amount of time. Okay, and then we also have like at the application layer. Okay, so the same thing really in this layer, but this layer here we're looking at the application, which could just be like the Windows operating system, but also like what we have for our LMS, like our Brightspace system, right? You have to log in and verify who you are, and your bank account. If you do online banking or whatever, right? You have to log in and verify who you are. And then at the next level of application, so there's kind of actually 2 application layers. There's like a local application layer, and then there's like if it's a database or something, there's a remote access. And then there's just straight data security. So data security is looking more at kind of 2 aspects. One of them is to protect your data from being stolen, right? So you want to prevent your hackers from getting it. So like for instance, if you do a backup, which you should do for the other aspect of data security in case, of a hardware failure on your system, that you have a backup of it. But what do you do with that backup? You need to make sure that it's stored in a safe place, maybe have a copy off site, things like that, because if something like a fire or something along those lines would happen, your data along with your computer would get destroyed in the fire. So you have to have a backup somewhere that was protected from that, so that you can access your data. But again, you need to, you can't just store it outside in a cardboard box and somebody can come along and take it, right? So you want to protect that data from hackers or people who shouldn't have access, but you also want to have that backup so that you can access it if necessary. And then layer 7 is looking at mission critical assets. So when you think about your business, there's certain things that you do in your business that kind of make you unique. And I got a couple of examples here, like the Coca-Cola recipe or the Kentucky Fried Chicken recipe, right? These recipes themselves are, critical to that business. And, if it was stolen, then other people could copy it. And, since they have the exact recipe, they could make it pretty much identical and cut into your production. So you need to make sure that these things are also kept safe. All right, so when we're talking about security, one of the big things that comes up is encryption. So encryption basically refers to scrambling your data so that if it is somehow obtained by a third party, they cannot actually do anything with it. They can't read it. So you need to have, you encrypt it based on an encryption key, and then you have to have a decryption key, which most of the time the decryption key is not identical to the encryption key. They're two different things. So the way that you encrypt it, you actually need a separate key to decrypt it. All right, so when you generate a key, it's kind of like a lock. So if you think over here, if you look at this master lock padlock here, right? When you go and buy a padlock at a store, you don't just buy the lock and then go to a different store and buy a key and hope it works, right? They come as a set. And so when you generate your keys, you get both what they call the public key, which is kind of like the lock, and then the private key, which is the key that you would carry around to unlock the lock. When we're doing internet type of communications, we use what's called secure socket layers, SSL, and that is actually built on top of another tool called transport layer security, or TSL. And the way this works, because like when you go to Amazon or your bank or whatever, right, you don't have them, usually they don't issue you a direct key to access their website. But what they do is they generate a public key that you can get access to. But then you need to make sure that whoever hands that public key out, that they're certified. So we have what we call a certified authority. So if you're say you're trying to set up your own web service, then you would have to generate a key, public-private key set, and then the public key, then what you would do is you would create a certificate for that and send it to an authorized certificate authority, and then the browser will automatically check for that then when it comes to your website and is asked for the key. You can also self-sign your certificates so that you don't have to use this third party. and then you can just hand out their certificates to people you want to use that. And anybody else trying to access it, they would not be able to do that. So why are we going to use encryption? Well, obviously, it's to prevent anyone from reading our data that we don't want to get a hold of it. But it's, some data isn't necessarily all that private, but it still will help keep hackers from accessing or doing malicious activity. Right. So, as we mentioned before, our firewall is our basic perimeter security for our network. And so it's our first line of defense here. And the way a firewall works is we already talked about in the networking lab about you send packets of information. So that packet has like the address and the port number and the return address, and all that information is in that packet. But these packets, they also have what's called a state. And so we have what's called a new state and an established state, and then there's some other ones. But so, how do you prevent a hacker from getting inside your firewall? Well, basically, when you first initiate communications, let's say that you're going to open up, you're going to try to log into the Brightspace system to do your homework or something. And so what you're going to do, right, is you open up your web browser and you click on the link to take you to the Brightspace login page. And what that does, the very first packet that is sent over has this state of new, because you haven't communicated with the system for a while, right? And so you're just establishing this connection, so you're sending out a new packet. Now, when you send out that new packet, then the Brightspace system, when it returns the information that it needs to return, it then sends an established packet. So the established packet is able to come back through the firewall. But by default, the firewall will block any new access coming through from the outside into your private network. And so these states is how they can kind of tell if somebody has connected, if they're making a new connection, or if they're just sending stuff back from a previously initiated, which would then be established. Okay. So a lot of times in the company, we'll set up something referred to as a DMZ, or demilitarized zone. And the idea here is that, if you're setting up your own web server, you need people to be able to access those aspects of that web server that you want them to be able to do. So what you do is you set that computer outside of your main firewall, but you don't just like put it out there all by itself on the internet so anybody can access it. So what you do is you put it in a special area. It's outside of your main firewall, but it's still behind a firewall. But it does allow new packets to come in, but those packets are restricted to certain types of packets. So not just any packet is allowed in. All right, so this is probably a pretty obvious slide here, but the results of poor security can easily result in the loss of information. You could have your bank accounts accessed, passwords stolen, loss of equipment, ransom, and just general embarrassment and loss of company reputation. So, these are all reasons why it's very important that we have good security.